Okay, this is a continuation of the first video on tan theta, which equals sine theta on cos theta. Exercise 2.5 Mathscape, just a few more examples. Question 6, solve the equation sine theta equals cos theta, where theta is an acute angle. Now, we know that if we do sine theta, so if you have an equation that says sine theta equals cos theta, we know that, for example, sine theta divided by cos theta is tan theta. So what we're going to do here is divide both sides of this equation by cos theta, okay? So we've got sine theta equals cos theta. I'm going to write it again. So sine theta equals cos theta. I'm going to divide both sides of the equation by cos theta. So sine theta over cos theta I know is tan theta, and cos theta divided by cos theta is just anything divided by itself is 1. And so therefore theta, you just use your calculator, tan of what is 1. So theta is tan to the minus 1 of 1, and you will get 45 degrees. So therefore theta is 45 degrees. So in other words, if you just want to check your answer, sine of 45 degrees, if you do that on your calculator, you'll get approximately 0.707. Same with cos 45. It is also approximately 0.707. Okay? All right, now for question 7. It's similar to question 6, but we've got some numbers there. So again, it is of the format sine theta equals cos theta. So what we do for this type of equation is we divide both sides by cos theta. And you should show that that's what you are doing. So you might want to rewrite the question and then divide, and even put it here, divide through by cos theta. Now we know that cos theta is cancelled to give us 1. So therefore we've got sine theta over cos theta, which is tan theta, equals 2. And again, using your calculator, theta is tan to the minus, theta equals shift tan of something is 2. So to find the angle, it's just shift tan of 2 using your calculator. And if you could give this answer, please, in degrees and minutes. And for this, in degrees and minutes, we get 63 degrees, 26 minutes. So if you wanted, for example, like check your answer, left-hand side, sine of 63 degrees, 26 minutes. Of course, there might be a little bit of a rounding error. So I'm just going to do that. Sine 63 degrees, 26 minutes. I'm getting approximately 0.89. And if I do 2 times cos of 63 degrees, 26 minutes, just evaluating that on your calculator, 2 cos 63 DMS 26 degrees minutes seconds button, I also get approximately the same 0.89. Okay? All right, now with this question here, again, if you've ever got sine theta equals cos theta, you always divide by cos, because what we want is sine theta divided by cos theta. So I'm going to write the question out again. I'll deal with the numbers in a minute. But let's just do one step at a time here. I'm going to just divide both sides by cos theta. Now, notice over here, if I'm dividing both sides by cos theta, here I'm going to get 1, where the cos theta is cancelled, but I'm going to get 6.4, and this is going to be times 1. But over here, I'm going to get 3.9 times tan theta, because sine theta over cos theta is tan theta. Look, I'll just do that. So I'll get 6.4 equals 3.9 times, because it's the times here, sine theta over cos theta is tan theta. Now, to get tan theta to be the subject, you would divide by 3.9. So 6.4 divided by 3.9 equals tan theta. So now to do that on your calculator, theta is tan to the minus 1 of all of this, so brackets 6.4 over 3.9. Now, if you do evaluate this, you may not get, you don't want to have some rounding errors, so I just go shift tan 6.4 divided by 3.9, make sure that's either in brackets or use the fraction button. Okay, so shift tan, maybe using your fraction button, 6.4 over 3.9. Make sure you close your bracket as well. And I'm getting 58.64, changing that to degrees and minutes. 58 degrees, 38 minutes, 34 seconds. That would be closer to 58 degrees, 39 minutes. If you want, you can check your answer. 6.4 times cos of 53 degrees, 39 minutes is approximately 6.4 cos of 58 degrees, 39 minutes. I get approximately 3.33-ish, roughly. And if I check the other side, 3.9 times sine 58 degrees, 39 minutes, I get approximately 3.33 as well. All right, slightly different, but both approximately the same. Remember, these are rounded off answers. So that one looks fine as well. Okay, now in the further applications questions, we've got question 8c. And again, pretty much similar to question 7, but the equations are a little bit more, just a bit different. Here, look, there are a few ways of doing this. You can either turn both equations upside down, or you can just do some rearranging. So what I'm going to do, first I'm going to take the reciprocal or flip both sides. So instead of root 5 over cos theta, I'm going to write this as cos theta over root 5 equals sine theta over 2. Now you're allowed to do that. Remember, we want to, so this is one way of doing it. I am going to show you another way of doing this. So now remember, if you've got anything like sine theta equals cos theta, you always divide through by cos theta. Okay? I think this method actually might be a little bit. So I'm just going to write what I've got. Now, if you're dividing through by cos theta, we just put the cos thetas down here on the denominator. So I'm dividing through by cos theta. Now, I'm going to show you an easier way than this in a minute. And remember, sine theta on cos is tan, and cos on cos is 1. So I've got 1 over root 5, and this is tan theta, but I've still got, because the sine over cos becomes tan, I've still got a 2 on the denominator. Remember, in here, instead of divide by 2, if you want to get rid of this 2, it's times by 2. So we've got 2 times 1 on root 5, which is 2 over root 5 equals tan theta. And then you can just use your calculator to work out theta. Now, I'm going to show you another way, as I said. So shift tan of 2 divided by the square root of 5. Make sure you either use brackets or 41 degrees, 48 minutes, 37 seconds, so approximately 41 degrees, 49 minutes. Now, there is another way of doing this, which is a lot simpler. So when you've got fractions of the form fraction equals fraction, you can just swap what's on the denominator on one side diagonally with what's on the numerator on the other side. Now, we tend to do this when we're doing, when we are in trigonometry, for example, when there is an x on the denominator. So, for example, if I've got something like, if I'm trying to solve this, tan of 30 equals 5 over x, remember we swap the x with the tan 30, we go x equals 5 over tan 30. So we're doing a similar thing up here. So I'm going to swap, because I want sine theta over cos theta, because that equals tan theta. So why don't I swap the sine theta with the root 5? So I've got sine theta over cos theta equals 2 over root 5. So all I've done is put the sine theta up here and the root 5 down there. Well, sine theta over cos theta is tan theta, and tan theta is 2 over root 5, and so therefore theta is just tan to the minus 1 of 2 on root 5, which is 41 degrees, 49 minutes. So you can only do this if you have fraction equals fraction, where you can swap diagonally across the equal sign between numerator and denominator. Okay, now for question 9, prove each of the following identities. This identity is saying that sine A times cos A divided by tan A equals cos squared A. Now this cos squared A really means cos of A times cos of A. Okay, so when we have cos of A times cos of A, we don't write it as cos of A squared. We actually write it in this shorthand notation, cos squared A. That means cos of A times cos of A. So just keep that in mind. So when we prove these identities, we always start off with the left-hand side with what we've got. Now the left-hand side is sine A cos A divided by tan A. And what I'm going to do, I'm just going to play with that left-hand side. I put left-hand side equals that. And I'm going to keep manipulating it until I end up with this cos squared A. Now I know that this is sine A times cos A divided by, because that's divided by tan of A. The reason I'm doing this is that I can write tan of A as sine of A over cos of A. Okay, so this is sine A times cos A divided by tan A, which is sine A cos A divided by sine A over cos A. Reason is I'm dividing by a fraction. That's why I've written the division sign here instead of leaving it as over. So I've got sine A cos A times, change the divide to a times and flip this fraction, times cos A over sine A. Now this is over 1. There are multiplication symbols between the sine A and the cos A and between this as well. So there are all multiplication symbols, which means that you can cancel between numerator and denominator. Remember, when you cancel, you're left with 1. So therefore, we've got cos A times cos A, which is, well, I can write it like this, cos A times cos A, which is cos squared A. That's how we write it, which equals my right-hand side. Okay, so therefore that identity has been proven. So on the left-hand side, we've got tan A times cos A divided by sine A. So tan A, we've got to be very careful. What I'm going to do, I'm going to keep this tan A on its own because I want to write the tan A as sine A over cos A. So this is really tan A times cos A. Now, as long as the sine A is on the bottom, it's okay. I can put the sine A over underneath either of those. It doesn't matter, because if I multiplied, I'd get tan A times cos A. And on the denominator, let's say I put this as 1. I've got 1 times sine A. I will still get that. The reason I'm keeping the tan A on its own is because tan A itself is sine A divided by cos A. Okay? I don't need this over 1 either. So what I've got is that tan A is, or I could have actually gone like this. I've got sine A over cos A, that's for the tan A, times cos of A divided by sine of A. So, but if you do it like that, then you've got to work out where this is going to go. All right? But I can do it like that, because if I do it like that, I can just say sine A over cos A times cos A. I can just pretend I don't have the denominator, or I can put the denominator over here. Okay, so I can say, if I want, I know I'm sort of going off on 2 different tangents. I could go that way, or I could go this way, right? So let's say you did do it like this. Sine A over cos A times cos A divided by sine A. You could do your cancelling here now. Or, if you're not comfortable with that, you can say that's sine A over cos A times cos A. And instead of this big divided by sine A there, I can just put divided by sine A over here, which is sine A over cos A times cos A. Now, divided by sine A means times 1 over sine A. Okay, so now I've got fraction, whole not like just a numerator here, so I can put it over 1. Everything is times, and I can start just cancelling. The sines cancel and the coses cancel, and I'm left with 1. Okay, the other way is, so that was one way. The other way is to write the tan A separate, because you know you're going to write it as sine A over cos A. And if that's on the numerator, it stays on the numerator, and this is on the denominator. So I've got tan A is sine A over cos A, and over here, times cos A over sine A. Again, fractions multiplied by each other, cancel out between numerator and denominator. And we've got 1 times 1 is 1 on the numerator, 1 times 1 is 1 on the denominator. So they both equal 1, which equals the right-hand side. And so therefore we've proven this identity. So we've proven that identity. Okay? And the last one is to prove that sine squared A over cos squared A is tan squared A. So I'm going to start with my left-hand side. It's sine squared A over cos squared A. Now sine squared A means sine A times sine A, and cos A means cos A times cos A. Now, I can break them up. So that's sine A over cos A times sine A over... Actually, no, that's a bad way to do it. I'm going to do it another way. Just rub that off. I mean, I could do it like that. That's correct. Why don't I just do it like this? That it's sine A over cos A, and they're both squared. That looks better. Okay? So that's sine A over cos A, and they're both squared. That is just tan of A squared, remember, which we write as tan A squared. That's actually how we write it. which equals right-hand side, or you could have actually come back to this. That's sine A times sine A over cos A times cos A, which is sine A over cos A times sine A over cos A, just breaking them up. That's fine. I can do them in any way I want, which is just tan A times tan A, which is tan A squared, which is tan squared A, which is how you write it. Okay?